Hello, and welcome to Backer Breaks It Down. In this episode, I'm going to talk to you about concavity. Okay, and we're going to determine the concavity of function, yes, simply by looking at its graph, but we're also going to see how can we do this numerically and algebraically. Okay, and that's where I'm going to start. I'm going to start with the algebraic numeric approach to concavity. Okay, so concavity. So you'll notice those two diagrams in the upper right-hand corner of your screen. You've got concave upward and concave downward. And they're using slope to help us describe concavity. So the graph of a function is said to be concave up if its rate of change increases as the input values increase. So rate of change. You've calculated rate of change before. It's also known as slope. Okay. Originally, when we were introduced to rate of change, this was our formula. F of B minus F of A divided by B minus A. That is simply the function notation for rate of change. We can totally calculate rate of change just like slope by going y2 minus y1 divided by x2 minus x1. So both of those formulas say exactly the same thing. So a function is going to be concave up on an interval if the rate of change is increasing. So I will need to calculate at least 3 rates of change in order to determine if it's increasing. So it follows that the graph of a function will be concave down if the rate of change decreases. Okay. So we can look at increasing, decreasing behavior in two ways. Okay. When we simply determine if a function is increasing or decreasing, we're looking at the function values. So in this case, we'd be looking at those values in the S column. And it goes 40, 72, 128, 230. I think we can all agree that those values are increasing. But that's not what we're looking at when we're determining concavity. To determine concavity, we need to look at successive rates of change. So that's what I'm going to do. Okay, I'm going to have to calculate 3 successive rates of change. So I'm going to start with the first pair of data, and I'm going to calculate the rate of change. So I'm going to go y2 minus y1 divided by x2 minus x1. And so I end up with 32 divided by 10, which is simply 3.2. So that's the first rate of change. Now calculating one rate of change isn't enough. I need to calculate at least 3 rates of change to determine concavity. So I'm going to take a look at the next successive rate of change. And I'm going to calculate it out. So I'm going to go y2 minus y1 divided by x2 minus x1. Let's see, that gives me 56 divided by 10, which is 5.6. And then I'm just going to do that one more time to give me a third rate of change so I can say for sure whether or not this is going to be concave up or concave down. So for my third rate of change, I'll use the last 2 data points. And then I'll go y2 minus y1 divided by x2 minus x1. Okay, so check this out because I've already done this. So what do you notice about the rates of change? It goes from 3.2 to 5.6 to 10.2. So since the rates of change are increasing, what this means is that my function is concave up on this interval because it's concave up if the rates of change increase, and concave down if the rates of change decrease. So the function values tell me my function is increasing. The rates of change tell me it's concave up. So let's take a look at problem 2. I've already calculated the rates of change. Okay. So I want to know, is this an increasing or decreasing function? And is it concave up or concave down? Looking at my, Looking at my function values, it goes 0, 20, 35, 45. My function values are increasing. Looking at my rates of change, they're decreasing. So what that means is that this is concave down. Okay. So concavity has nothing to do with increasing versus decreasing. Basically, what this would look like for increasing concave down, it would look like this. That's what the curve would look like, because concavity is really just describing how it curves. Does it curve up like a bowl or down like a dome? That's what concavity is. Okay. So in problem number 3, once again, I've already done the math. If we look at our D values, we'll notice that those are decreasing. So this is a decreasing function. If we look at our rates of change, we'll notice they are also decreasing, which means this is concave down. So decreasing and concave down would look like this. So speaking of looking at a graph to determine concavity, we can totally do that as well. All right, so if the graph bends upward, it's concave up. See, bending upward. If the graph bends downward, it's concave down. Okay. If a function has a constant rate of change, its graph is a line, so it won't be concave up or concave down. But one thing I want you to notice about concavity is concavity has nothing to do with increasing versus decreasing. If you look at the graph on the bottom right, you'll notice right here, it's concave up, but it's decreasing. And here it's concave down, but it's decreasing. Okay, so concavity has nothing to do with is my function increasing from left to right or decreasing from left to right. Concavity has everything to do with the bends. So the graph bends upward if it's concave up, like a bowl, and the graph bends downward if it's concave down, kind of like a dome. So taking a look at these examples here, it says for the given interval, determine whether the graph is concave up, concave down, or neither. So number 4, we want to look at from 0 to 1. So x is 0 to x is 1. Okay. So on that interval there, I'd have to say it's definitely curving down like a dome. It's subtle, but there is a downward curve to it. What about from -3 to -1? Okay, so -3 to -1 would be this interval right here. I think we can all agree that that is curved up like a bowl. All right. So what about the next interval from -1 to +1? Okay. So that one I feel is also kind of obvious. -1 to +1 is this right here. And that is definitely down like a dome. What about from 1 to 2? Yeah, I'd agree that it's kind of upward. From 1 to 2, it's kind of curved upward. What about from 2 to 4? Yeah, those are very linear. So I'd have to say that's neither, because it doesn't have any curve at all. And then lastly, what about from -4 to -3? So this right here. Yeah, that would be down like a dome. So concavity can be determined graphically, just looking at the way the graph curves. Does it curve up like a bowl or down like a dome? Concavity can also be determined numerically and algebraically by looking at the rate of change, because if the rate of change is increasing, then it's concave up. And then if the rate of change is decreasing, then it's concave down. And that's how Backer breaks it down.